So just to be aware, yeah, we're recording the session. What happens with these recordings is these are sent then back to IWFM Corporate, who upload it onto their website. And it's also available on YouTube afterwards as well, should anybody need it, and can be part of the broader library. So some of the activities that we've had over the last year and for the year ahead can be seen here. So even last month we had digital software selection tool with Infosight. Obviously today we have the indoor air quality with GPS Air. Next month we'll be doing managing complex change, and that's with Live Unbound. And that's actually going to be in the Cork office, in Cork. So one of the things we'll be looking to do for the year ahead is actually kind of doing a bit of a roadshow where we'll have networking events beyond Dublin. So the expectation is that we'll be in Limerick, Galway, maybe Sligo, Waterford, other parts of the country also. So look, it's just the start of that. We also have the FM lunch in the Gibson Hotel in May. So there'll be plenty of notice come out on that. And then in June, we also have a session on contracts, particularly discussing TUPE, redundancy in the forms of contracts that are out there. Just kind of a reminder, I suppose, for everybody why we're here and what the purpose of the committee itself is. So our role is to, I suppose, implement the vision and strategy that has been developed by IWFM. So we want to be the voice of our members and of industry. We want to provide insight, I suppose, as to what the latest trends and patterns are kind of globally and how these might be applied. We want to create communities where people can learn together and share, just like we're doing here today. And we want to be a development partner for individuals who are looking at career development. And ultimately, you know, improving everyone's capability in terms of how to deliver facility management and workplace and activities and services. This is the team, I suppose, that brings you this today. So we meet every 2 weeks or so, just for half-hour sessions, look at kind of what other activities are out there, what we're trying to achieve, how do we integrate further with industry, with plans are afoot already around, you know, how we're going to approach other professional associations, third-level institutes, and effectively kind of bring in more to our members and that integration. So today's discussion, I suppose, when it comes to indoor air quality, which is complicated, and there are no silver bullets. No standards defining what is good or bad air indoor quality, which this will all be discussed in more detail shortly. So thanks for everybody for joining here today. I'm going to introduce Alpesh. Alpesh, General Manager, EMEA and APAC at GPS Air. Enthusiastic, educated and experienced marketing and new business development professional. Long-standing experience in formulating and implementing key growth and new business development strategies. So Alpesh is going to talk to us today about HVAC and the indoor air quality and the tools that can be there to support that. So Alpesh, I'm going to hand it over to you there. Thanks.
Thank you, Conor. That's good. When I read that bio, it looks like it's an AI written, but it's me who spent some time. But thank you, I appreciate that. And I think one thing I've learned in IEQ is like it's evolving. It's really complex. So I'm going to share my screen now. So hopefully you can see my screen. Sorry, that's messy. Right, I suppose you can see my screen now.
Yeah, that's presenting now, Alpesh. Yeah, great.
We can see that.
Right, I'm just gonna move that to go to presentation mode. So yeah, so my name is Alpesh for GPS Air. I'm gonna talk about a little bit about indoor air quality and hopefully, you know, share the kind of learnings and experiences and hopefully learn from your experiences and your questions. I'll run through the presentation. I'll try and be brief. And I would then have a follow-up material, which I would send it over to Derek and Conor and my contact details. I want to also acknowledge we have a partner, IBC, who are supporting. So as a follow-up, you know, I'll share their details as well in that. I'm on a single screen, so if you have a burning question, just interrupt me. But I think we have we would have good 10-15 minutes for Q&A at the end. So if we can run through presentation, hopefully that would cover some of the questions you may have. And then we'll run into Q&A. But like I said, if you have a burning question you want to ask, just interrupt. Thank you. So yeah, I mean, just some of things we'll go through. I think air quality or indoor air quality is a massive topic. So no way you can conclude in a single slide or in our 45 minutes. But I think we just look at the overview and some of the top end tools which we can practically adapt. So we're gonna just look at some of these things: introduction, growing awareness. Some of things might be familiar, some of things might be new to you. So that'll be good to see. We look at some of the air cleaning technology, including the ionization, which is where I would want to focus some of the part to kind of educate, and then followed by Q&A. So I always start, again, like I said, if you think about air quality, right, it's difficult for me or anybody, to be honest, to put in one slide. But if you think about indoor air quality, I would just encourage each of us to think about what does that mean to you as an individual. When we talk about indoor air quality, what is it and how does that impact? Does it matter to you? So it's just more of a thought process, right? But it is clear that air quality and well-being are very much important topic for everybody, be it government, be it employers, be it for the general public, right? It's very much evident that poor air quality is recognized as a significant factor for a number of kind of conditions, be it heart disease, lung cancer, asthmas, and so on, right? And I think post-pandemic it is even more visual, and on our thoughts and minds. So if you think about air quality or indoor air quality specifically, you look at DEFRA, for example, Department for Environmental and Rural Agency in the UK. They provide what is called Daily Air Quality Index to monitor outdoor air quality, and they measure 5 outdoor pollutants. I'm just going to take my laser pointer. Some of these you may recognize, and they measure these across 1,500 sites in the UK. You may agree, and if not, then we'd like to hear that. But typically there is a growing awareness of indoor air quality. Increasing publicity around IAQ. Like I said, the bad effects of COVID pandemic. A number of research have come up, have been done around linking the office work conditions and concerns with IAQ and general well-being, right? Seasonal flu, and so we all know how that spreads. So generally, that's kind of a growing an element, and I think that's why one of the reasons we are probably here to discuss or see what we have to kind of go through, right? One of the biggest challenge, and this kind of goes across in the globe, but typically in the UK and Ireland, and or even Europe, right? There are kind of no legislation on indoor air quality. There are no kind of clear standards. And I know I'm referring some of the things in the UK. You may have slightly, but I believe you follow the same in the Southern Ireland. But if you look at recent Part O, for example, which deals with the overheating, in the dwellings rather than indoor air quality, so there are no legislations across for indoor air quality, which means it's a challenge for building owners or employers, to anybody, to understand what is good air quality, right? What does that mean as an indoor air quality? What is good or bad? So I think that's where we're coming from. But if I look at the DEFRA, which I mentioned about Daily Air Quality Index, perhaps that could be used as a proxy for indoor air, where they measure particle levels in the air in terms of concentration. Lower the particles in the air, the green the band is, and higher the particles, which is typically particles being dust particle, it goes kind of moderate to high. So the essence is lower the particle, better the air. I think that's enough thought. So here's the link, and like I said, I can forward that on to her look. So that could be a good indication of how air quality could be measured, right, or thought about. Like I said, there are no legislations. However, through the UK, there's something called UK Human Rights Bill, Clean Air Bill, going through the House of Commons, which is at the moment second reading. The idea for them is to kind of update and combine several different regulations, guides, be it WHO, CIBSE, and likes of them, and create one standard for indoor air quality, which can then be enforced and measured. Of course, I think that's going through the second reading House of Commons. That would take some time, but I think that shows how important that is to everybody, right? So that's something happening, right? If you're a building owner today, what are you doing about indoor air quality, right? or we're gonna wait until that hits the hammer, and all of a sudden we say, what do we do and how do we cope up with these things, right? So eventually it's on the premises that clean air is a human right, and there'll be a governing body to enforce and oversee that. I think the timing is not clear to us with number of different priorities, but I think it's important and critical it's there. So I think it's good for us to know that's coming as a legislation. While there are legislations being discussed in House of Commons and around, there are certain resources available in the UK, Europe, and from ASHRAE. So I've just mentioned some of them. BISA, for example, in the UK have issued some of the guides around indoor air quality and some best practices. Well, in BREEAM have included, they have elements of IAQ to kind of guide what can be done to improve indoor air quality. British Council for Office have similar guidance. ASHRAE in the US 62.1 have a clear kind of standards and guidance around ventilation for indoor air quality. Recent standard ASHRAE 241, which kind of typically addresses control of infectious aerosols. So these are the resources available. I also want to kind of focus on one specific kind of standard which was recently introduced end of last year, which is the BS 41021 2023. Which addresses the overall EQ, which is the indoor environmental quality, which talks about air quality, light quality, thermal comfort, acoustic and sound quality. And as part of air quality, you would notice that their focus is on how to manage CO2, but also how to reduce pollutants in the air, which is the particles. So I think that's a good guidance, and that's kind of the direction it's going. It's important to note, again, this is not a legal standard. It's more of a code of practice. It kind of gives some kind of guidance or base. If you're considering, or want to explore, how can you approach indoor air quality? So I think I would recommend accessing this and kind of going through in your time. Just kind of talk about indoor air quality, right? I mean, when we say, like I said, start of the presentation, what's an indoor air? I mean, what is it? And to me, have kind of I've spent good 3 years working with this company and discussing, attending seminars, things. But one thing is common, that yes, indoor air quality is complex, but it's also a mixture and cocktail of your outdoor and indoor activities, right? We bring in outdoor air, so a lot of pollutants, be it traffic fumes or combustion products or whatever. Also, things we do indoor, right, kind of causes the pollutants. Things like bacteria, viruses, they spread human to human. So indoor air is really kind of cocktail of everything. I think with this picture, just like to kind of address that some of the things we could see, but a lot of those elements or pollutants or particles we don't see with the naked eye. And that's the biggest challenge in the indoor air quality. So I think that's where we are, right? What is WHO? So WHO, again, on terms of air quality, they focus on 5 kind of key pollutants: particulate matter, ozone, nitrogen dioxide, sulfur dioxide, and carbon monoxide. You kind of talked about particulate matter or PM. You may be familiar with PM 2.5, PM 10, or particulate matter. Or in simple layman's term, I could say it's a dust particle, right? And we don't want to be having in our lungs. The way they're measured or kind of calculated is in the particulate matter size, as in 2.5 or 10, which is the micron, which is the millionth of a meter. Typically, the filters are rated based on the PM10, PM 2.5 you might have seen. The point here really is smaller the PM, smaller the particulate matter, or smaller the dust particle, deeper they go in lungs. And I think that's thing, and I think the whole idea is how can we reduce these pollutants which are in the air, and clean the air. That's the kind of more, the message behind it. WHO again has guidelines around the mass concentration, what they call is Air Quality Guide 2021. They previously had updated that back in 2005, so it took about good 16 years for them to kind of update their guidance, but they kind of reduced their annual concentration and 24-hour concentration level. So here what they're really recommending or guiding is the annual kind of concentration levels of particles in the air. The particles will be measured in mass concentration rather than size. So, it's like I was showing you in the previous slide for that. So again, it's a guide, but again, it shows that that does matter to everybody, including WHO and so on. So it's becoming, increasingly important. From WHO, there are no target dates, in terms of, what is indoor air quality and how it is. They're looking at a broader worldwide picture. They generally promote this continuous improvement. So rather than having a kind of a rapid cut deadline, and then their role is to kind of, foster the greater health benefits around these things and so on. So then it's kind of support the whole idea of improving the indoor air quality. I think one of the challenges in discussing some of the building owners and consultants is when you refer to WHO specifically guidelines is then the WHO does not consider bioaerosols, or pollen or mold or viruses. So again, which has an impact to us as living bodies, or if you're a building manager or estate manager, how do you address these things, right? Because these things are important. So it's just something to just know about. I just want to talk about like particles things, or what they in science term it's called bioaerosols, right? But think about it as a particle, right? Allergens, common spores, bacteria, viruses. What we are looking here is their sizes, right? So these are typically measured in micron. So micron being a millionth of a meter, so minute we cannot typically see that from with naked eyes. And you'll see in a couple of slides after this what I'm kind of, probably makes sense to have a visual of that. But you see typically all the bacteria and viruses are typically less than 1 micron, so very ultra fine particles. The other thing is also the importance of settling time. So you look at different particles or allergens or spores or bacteria, they all have a different settling time. So this is a scientific kind of studies, of course. What it means is, let's say, for example, a bacteria could be active up to 475 minutes, or any virus, could be active up to 13 days, right? So more they're in the air, they could be, and this is an average, of course, thing, but it's important that more they're in the air, more dangerous for us, or human beings, as they breathe in, right? So again, the idea is these being particles, how can you get rid of that, right? That's a kind of thought process, I'm kind of heading towards. So just kind of setting the context here. Yeah, I've been talking about particulate matter, or PM, right? So this is just a visual. You can see this online as well. This is not something we have created. We're just using to show the visual what it means. So if you think about human hair, although this is a bit funny, it looks like a dinosaur tail, but think about this as a human hair. We can touch it, we can feel it. Typically, it's 120, 130 micron as an average, depending on genes and so on. But that's kind of thing you're looking at. Then you come down to fine pitch sand, grain of salt, white blood cell. So you can imagine, that skin cell maybe, which is very minute. And then you kind of come down to PM10, which is the dust particle. This is where you'll start getting, challenging respiratory droplets, dust particle PM2.5. And then you come down less than 1 micron, which is really a nasty zone, which is typically bacteria, viruses, wildfire smoke, coronavirus, Zika virus. So that kind of zone. So it kind of gives you a perspective of when we talk about, what these particles are and what is the relative size, right? So this is a similar view, and this has been published by a National Air Filtration Agency, based on a number of studies. This was also released in ASHRAE IAQ guide back in 22, following the pandemic thing. What we're looking here is, what is a typical distribution of these particle sizes, right? We talked about particle size in the earlier slide, but how does that matter, and what are they, and what do they do, right? So, and then kind of focuses on how can you, remove those particles from the space. So here we are looking at particle size in microns. So, 30, 10, 5, 3, and 1, and, kind of less than 1. And it kind of just depicts the size. These are the typical ultrafine particles. Sorry, just go get rid of this. Looking at what we are seeing here is, if you see the percentage by particle count, 98.5% of particles in a typical atmosphere are less than 1 micron, right? And that's just for a sec, think about it. Of course, we don't see them, right? But knowing these are typically a kind of a nasty zone, 98.5 are less than 1 micron. The relative weight by percentage is only 3%, right? And that's the challenge, is these particles are virtually weightless. So typically, they don't move with the general ventilation flow, right? So things like, if you think about less than 1 micron, typical bacteria, viruses, if I may take example of SARS-CoV-2, which is the COVID they were suspended in the air, right? They are typically, SARS-CoV-2 is about 0.3 as an average micron, right? So much less than 1 micron. They hang in the air, we inhale in when we get infected, right? So I think that's a challenge. I'm not saying everything is bad, but I'm saying typically those less than 1 micron is the zone of bacteria and viruses. So that's a lot, right, for us to look at it or the digest. Excuse me. So I guess how can we address these? How can we minimize and how can we remove these from our space, right? That's the kind of a question for us. So as a manufacturer, what do we see or how do we recommend, to act on improving your indoor air quality? So we believe that step one is controlling its source. If you know the source of which creates indoor air pollutants, right? You got to look at it. Practically, can you reduce those things? Certain things we can, certain things we may not be able to do, right? But it's always controlling its source. Of course, achieving minimum ventilation, that's like absolute must, right? And then consider adding an optimized air cleaning technology. Why? You look at optimized air cleaning technology with the view that how can you reduce the ingress of outdoor pollutants, right? So if you think about outdoor air, I hesitate if you're in Dublin City or London City or whatever, I would hesitate to say outdoor air is a fresh air, right? So, you bring in outdoor air, not necessarily fresh unless you're in the countryside, thing. So, can you use any optimized air cleaning technology? And importantly, when we saw earlier that 99% or 98.5, be precise, are less than 1 micron, how can you reduce them significantly within the indoor space, right? So that's an approach we see and, we kind of advocate for as a manufacturer. I'll just quickly touch on the filter specification. You may be aware that part of ventilation filters are important. Filters typically rated as ISO rated based on their testing criteria. They are basically certified according to the efficiency of capturing these particles. So if you see PM1 or PM2.5, basically it denotes their efficiency. So typically you'll see something called efficiency PM2.5 that denotes like 80% of the capacity, right? It is that arrestant, so it's how it captures the particle. That's how these filters are specified. Europe has a guidance on filter selection based on the outdoor air consideration. So again, based on your outdoor air, you want to select your filters. So again, minimize the ingress of pollutants from bringing in inside, right? And these are based on the WHO air quality guidance where, you have ODA1, ODA2 based on where you are. So that just kind of helps as a guidance. Again, the filter selection are also based on the supplier standard, right? So which is based on what is the concentration of these pollutants outside, and then you factor your filters based on that. So, just wanted to kind of give you a quick overview. So typically you look at the office environment, you probably have a supplier standard 2 or 3. Supplier would be typically a clean room or, a clinical environment. While you might say, why do I need supply air where, they are actually much higher than WHO. So if you think about the environment like underground car park or rubbish environment, when dumping in there, where that's where they would look at these as a realistic supplier standard. So just as a factor, like I said, I have a note which I can forward. So there's more reading, but just want to kind of mention about that. So I want to just take a couple of minutes on the optimized air cleaning technologies. What can you do besides controlling its source? Ventilation, having filters is great, right? But how can you address those pollutants which are indoor, which are suspended in the air? So you may be familiar with HEPA filtration or UV light, and I'm going to focus a little bit going forward on ionization as an added technology. But before that, HEPA, based on ISO standard, it can capture, particles 1 micron or larger. In terms of submicron, HEPA filters placed in inductor can capture up to 0.3 microns. Of course, HEPA has a challenge itself in terms of reduced airflow, putting pressure on the system, fan operation, and energy usage. HEPA could also bring higher capital cost and life cycle costs, right? But again, if you think from where the typically HEPA filters are placed, depending on, let's say, in a commercial environment on a return duct, however, all your particles are in the air, right, which are virtually weightless, so they're not moving. So HEPA filters kind of wait for these particles to come to them, right? So HEPA filtration is a passive air cleaning technology. HEPA does not go into the environment and capture them somehow. So HEPA works, but it's a passive technology. So you need some sort of mechanism to get these, ultrafine particles, how do they go to HEPA filters, right? For example, and that's why if you are familiar with clean room environment, they would have higher number of air changes per hour, because what they're trying to do is influence these ultrafine particles to move out, right? But in commercial environment, it could be really challenging in terms of cost, increase, cost of operations, energy, right? Especially in the retrofit environment. You look at ultraviolet light, again, it destroys biological particles. It doesn't really filter them, it kind of destroys them. Again, UV is kind of typically filtered on your duct, which is a passive solution, and it relies on the particles going through in the duct, and then rather than actually in the space. Again, the submicron particles with our 98.5% of the space are not directly impacted because UV is typically fitted in the duct, so it kind of helps with the restock side. So UV and HEPA we consider to be passive aircleaning technology. Again, with UV you have challenges of initial cost and life cycle cost. Our ionization, and I'll talk in a couple of slides going forward, is an active approach to cleaning the air within the occupied space. So ions, atom or molecule, I'll talk about it. They flow through the ductwork with the airflow into the space, and they address the particles inside the space. So they actually clean the breathing zone. So it actually also complements your existing filtration and ventilation system. It's part of a layered indoor air quality strategy. So it adds on to your existing system. So that's how it complements. But key thing for ionization is it requires airflow to carry these ions into the space. Like I said, ionization is a part of a layered approach to indoor air quality. So this is just a model I've put it up, but you can search for this Swiss cheese respiratory virus pandemic defense model by Dr. Ian. What he talks about is, no single strategy would give you 100% IAQ, right, or indoor air quality, because your air is constantly evolving. It's being polluted. Things are happening. So what all you're doing is, how can I add layer and mitigate the risk? That's the whole point. And this also going to set the expectations that, hey, am I going to have my air 100% clean? Probably not, because we do a lot of things with the air, right? We go out, bring in, cook food, clean the carpet, open the door. So that's constant thing. So the idea is, can you minimize the impact? Can you minimize the pollutants level? Can you minimize the pathogens in this space, right? So that's kind of a thought process behind that. By adding the layer, you're getting better. That's kind of more on the kind of indoor air quality. I mentioned about ionization. So what is ionization and how does that work? Some of you may be familiar or may have, so ionization is not a plasma or dielectric system or, that thing, ionization based on ion. So typically an ion is a particle. It's an atom or molecule or group of molecules. They're either negatively charged or positively charged. Ions naturally occur in space. So they are created by running water, waterfall movement, sunlight, striking lights. So ions naturally occur in the space. We will not be able to see the ions, but I normally carry ion meters, so I can measure the ions. So, so these are, like I said, kind of typically created from the movement of motor, lighting, and so on. Typically, if you go in a high, outdoor environment near waterfall, mountains, you will see the ion count, or I would say you would measure the ion count much higher because of these movements. What these ions are doing is, by the nature of electrostatic pressure, they are targeting the particles. So they, in a way, they're deactivating the particles. So when you go to these places near waterfall, and crashing waves, for example, these ions keep the pollution level low because they're targeting the particles. So you feel fresh, right? However, when we come to the city and urban environment, ion levels drop because we produce a lot of pollutants by a number of different activities: vehicle emission, cooking, office construction, so on. So ion levels drop in this environment. That's really what we're trying to do with this. How can you increase the ion levels into the space so they will address these pollutants? The principle of ionization works on agglomeration. So basically, it clusters together. So if you think about ions, they kind of do a few things. When ions come in contact with oppositely charged particle, let's say it's just for an argument, it's a COVID particle. We're in a meeting room, I'm exhaling, and let's say, I don't have, by the way, I have COVID, and these particles are there. So the ion, which then meets the particle or COVID particle, for example, I'm very specific just to kind of make it a sense. It neutralizes the particle. So the particle is neutralized, So it is the chance of somebody infecting because of that particle are much less because that particle is deactivated, the virus or bacteria, right? We cannot kill these bacteria, but typically you deactivate them. The other thing is, how do you get them out of the space? Because we saw they're virtually weightless. So the principle of ionization works on agglomeration or clustering. So because the process is continuous, right? The ions are coming through the airflow regularly. The airflow is going through your breathing zone. These particles keep coming together, and they form kind of a snowball effect. So smaller ones get together, because of this, and then they get bigger. Once they get bigger, they carry enough, mass concentration or weight. So either they drop on the floor or they get sucked into your return filter. So now your filter is capturing much more particles than before. So that's how ionization complements your existing ventilation and filtration system. And I'll go through that later if you have any questions on that. But that's how it is, that's how simply it addresses the particles in the space. Benefits of ionization. Ionization can be applied in new build and refurbishment projects. So, it's easy to adopt as long as you can have the airflow. You can get the ions in the space. It enhances the performance of ventilation system because eventually you are taking the pollutants out, you're making the clean air, so it helps with the ventilation system. It works in the air and heighter surfaces where the air goes. Ions do not penetrate inside the kind of things. It just kind of heighter surfaces where the airflow will touches, reduces odor, bacteria, viruses, because eventually, if you think about it, everything is a particle. So if you can minimize, odor, for example, is a great example. Odor, we've seen a number of applications where odor is like, virtually gone. So I think just important to kind of mention within ionization, there is a confusion about, I suppose not confusion, a kind of lack of education, understanding for a number of reasons that ionization is not a plasma technology. Ionization is not a old tube or dielectric system. And what I want to emphasize is the technology, soft ionization versus hard ionization. So soft ionization refers to ionization technology, which is charged. It charges the mechanism at a lower energy, and the ions released as they go in the space, all they do is they attach to oppositely charged particle. They do not fragment the particle in the air. So hence, soft ionization does not fragment. All they do is attach, deactivate, group it together and get it out, right? We do not fragment, or the technology does not fragment the particles. Because you do not fragment, it does not produce any ozone or byproducts. Very important. So soft ionization technology is the one you want. Typically, hard ionization, traditional technologies, break the molecule, and the moment you break, you have a challenge of additional ultrafine particles and ozone and even more. So just to kind of mention, that's very important that soft ionization would not produce, and the reason for that. Like I said, soft ionization is better for indoor air quality because low energy charge acts on particles without breaking them down. No fragmentation, no byproducts, and no further ultrafine created. For example, these are one of the module which also has a self-cleaning mechanism. So once you install, there are no replacement parts, low energy, and typical life cycle is 10 to 15 years. So in a retrofit environment, this unit uses about 8 watts of energy. So low energy, no replacement cost. So if you now start thinking about other options, you may want to think, okay, that might make more sense, right? By the way, just for record, the GPS devices are based on soft ionization and do not produce ozone or byproducts. Of course, we have all the certification for that. Again, avoid hard ionization on the back that all ionization does not work in the same way. They use high energy and they break the molecule in the air, and if you break that, then you have a challenge of byproducts and ozone. So just that's very important. ASHRAE has a clear guidance on ozone. Of course, it's undesirable product. The ASHRAE standard 62.1 specifically addresses that. All the air cleaning technologies should be UL2998 certified, which is basically the threshold of ozone 5 parts per billion, which is zero ozone emissions. So there's guidance, clear guidance available. Recently, CIPSE released a statement on ionization. So what does CIPSE say? So So I think one good thing has happened in the last few months. I would say this was launched end of October in London. I think in Sodex's office, you may be familiar with, is CIBSE Guide M. So ionization as technology being recognized and being more widely recognized around to deliver the indoor air quality. CIBSE Guide M released in 2023, section M15 under well-being. It recognized the bipolar ionization as a novel technology. Of course, they say cleaning is not a substitute for ventilation, like I said, but however, I think important thing is it can reduce the exposure to particulate contaminants inside the space. I think the term novel kind of sometimes scares people off, but I think the take we have as a thing is, and rightly so, they want to make sure that any technology being used, is effective and safe. Safe being, not producing ozone, any byproducts, because that's the thing. So that's how CIBSE view is. But it's great that they recognize the technology, and it's a start. Yeah, ionization in real world can be applied, like I said, in any indoor space with the airflow, both domestic, commercial. With ionization, what is important is how many ions can you get in the real space, like I talked about the waterfall scenario, right? So if you're in an office environment, how do you increase the ion levels inside the space? Because more ions, much less particles, because these ions will continuously target the particles. So that's more important in occupied space. You can measure the ion density by number of tools available, wall mount, or there's a handheld machine manufactured by AlphaSense, Alpha Lab, sorry, where you can measure the ion density to understand before and after results. Applying ionization, some of the designs potentially to avoid, because as ions pass through, they typically last for 60 seconds, because as they go on the way, they get consumed. So you want to mount ionizer module as closest to the space, not further away. So rather than mounting here, consider mounting here, because the ions will then go into the space rather than just getting lost on the way. If you have an airflow which is very stagnant or very slow moving, you may see low level of ion. It still helps, but just something to consider in terms of managing your expectations and understanding. And of course, if there's a very complex airflow path, what happens is as ions travel, they could meet oppositely charged particle and they could neutralize. So it's something to consider. But ideally, what we've seen is as close to the space, for example, you mount ionizer, that will have effect because you will get more ion density in the space. So that would be kind of how you look at in terms of applying it. We do have application guides. And then if you think about indoor air quality in general, like I said before, it's a layered approach and it's a continuous process, right? It's not a single point objective that you just achieve today and then leave it. It's a constant. So there are a number of monitoring devices and management systems available in the market where you can measure, excuse me, the various elements, PM1, PM2.5, VOCs, temperature, humidity, and then they give you access to that dashboard. Of course, ventilation is the backbone of any indoor air quality system. Filters are necessity. By adding ionization, it could actively clean your and enhance your system performance. So I think with this, I want to just conclude my my presentation here on the technology side. I think the only thing I have is a couple of slides for our partner IBC. But before I do that, are there any questions or anything I should address here? I don't know if there's in the chat or Conor, any questions? Should we open to the question now?
Yeah, I'd certainly open it up to those attending. If you have any questions you'd like to ask, Alpesh. Just maybe a few comments, maybe just to start off with Alpesh, from my perspective anyhow. There's no kind of legislation specifically around indoor air quality, but I suppose there is kind of a duty of care and, under health and safety guidelines, the need to provide a safe place of work is our starting point, obviously. And, under FM, we do have three main objectives, and that is to make, a safe environment, a comfortable environment, and a productive environment. So obviously this comes under the safe environment part there. In our own office in Cork, we moved about 7 years ago to a new building, and obviously the level of ventilation and filtration is far greater than it had been historically. And as a result, we've seen a good degree of, or a good drop, in fact, on sick leave. And, it's actually quite important, in terms of a cost that you may not otherwise see, consequential cost. And even I'm familiar with, individuals who have or have had asthma problems, and they have less of an impact now because of the improved air quality as a result of that. So,
Absolutely, I think absolutely. You said safe,
mm,
healthy, and I think productivity, because if you provide environment to yourself or your employees, your productivity goes, because sickness, and that's in the commercial environment, that's a big cost, right?
absolutely, yeah.
So
If
I
you're
think
feeling good inside a space and you're getting good fresh air, then you'll obviously be more productive. And obviously, if you're sick, you're not going to be productive. So
yeah,
it's the
absolutely.
obvious. So look, it's quite interesting, and you also brought in there about health and well-being. Something that
Correct.
we've seen. The word workplace, in fact, so we're now with IWFM, formerly British Institute of Facility Management. It's now the Institute of Workplace and Facility Management. And what we're seeing, I suppose, is that the word workplace has, we'll just say, it's having a far greater impact at board level than than facility management, simply because I suppose the CEOs, CFOs, COOs are starting to recognize the value of providing a high quality environment where people can be productive,
I
and the
agree.
need to provide that. And that it helps with attracting talent and retaining talent, developing the talent. And again, air is just one part of that, under health and well-being. So anybody that's looking at to kind of align with the UN SDGs, United Nations Sustainable Development Goals, this is another area where obviously they can demonstrate alignment with that. So, really, really important also.
Absolutely, and I don't know how that directly impacts in FM, but I guess if you think about lead points or well or pre-aim, if you look at the indoor air quality segment, their focus is removing indoor pollutants like PM1, PM2. How can you get rid of that? That's what it's being measured on. So, that's kind of, provides the credits and, towards that. So I think you're right, I agree that, these things are being recognized. I mean, SIBSI, the fact they put in the guide M maintenance guide as under well-being, that just says it's a start, right? That kind of just recognizes that as industry. But you're right, CEO, CFO level recognize the health and well-being. I think challenges today, it's more motive driven rather than legislation driven. But
Yeah.
legislation is a matter of time. So whether you want to do something today,
Yeah,
and yeah,
it's interesting that it's been driven. It's a kind of a push factor, but there's also the pull factor, the actual benefits that are derived that I mentioned there already. By having high quality air, you get higher productivity. People are less likely to be out sick and so on. I mean, since COVID, people are far more sensitive to the needs of high indoor air quality, and even it's quite normal now to see carbon dioxide counters and other similar sensors in meeting rooms, for examples,
true.
where these are being monitored on a regular basis. And I looked at this as a great thing. I suppose I just have kind of a few questions, maybe a few quick ones there. I'm familiar with the HEPA filters and ultraviolet light, I suppose to a lesser extent. I'm not very familiar with bipolar ionization. That was quite interesting there.
Yeah.
One of the things that comes to mind is the cost associated, obviously, not just the capital cost here, because ultraviolet technology isn't that expensive to buy, but it can be really expensive to run.
Absolutely.
So, in the same way,
Absolutely.
maybe you can give a few examples of a maybe a typical building or
It's
what that's associated, the cost associated with that.
No, Conor, that's a great point, because I think that's one of the things. If you look at HEPA or UV, you have a capex cost and then you have a running cost. The running
Mm,
cost runs into you're replacing filters in UV light, but also the labor cost, right? So there's second element. Also, if you
mm,
think about discarding filters or discarding UV lights, you cannot discard UV light just in a standard commercial. So there's cost. You have to have a specialist removal, right?
mm,
So you think about initial capex cost, the running cost of the energy cost, and the tubes replacement cost. So that's an element to it. Versus something like the needle point bipolarization. So here, the basic principle is, I'll just kind of show you here, is these are the needles. So these are releasing positive and negative ions, and they go across the airflow. This is the cleaning arm. So this cleaning arm cleans the brushes every 24 hours. So it keeps the brushes clean. So now if you mount this in a duct or a fan coil, nobody needs to go and clean or replace anything. This, you leave it on, it cleans every 24 hours. You have a continuous ions coming in. So to answer your question, most likely, and I could be biased, but most likely the cost of these would go out of your maintenance expenses, not even CapEx, right? And there is no running replacement or maintenance cost at all. This uses only 8 watts of power compared to any other system, right? So if you think about desk heater, that uses 3,000, right? So that's
8 volts. So.
yeah. So what we have done, a couple of analysis, realistic compared to UV or HEPA, the cost or life cycle cost of this could be 80 to 100 times less with the ionization self-cleaning technology, to answer your question. Of course, that would depend on different things, but
Yeah, the configuration.
you see your cost much less because it's one-time investment. Boom, that's it.
And Alpesh, can I ask a question there? So
Please.
you mentioned during a part of your presentation, and it was a great presentation. Myself and Connor both come from engineering background, so love the detail and love the numbers and everything else that comes along with it. But one question I have, you mentioned London City and Dublin City and a couple of other European cities such as Paris, but particularly with some of our client sites, and I don't know what some of the other FM managers in the call think, but client sites, particularly in Dublin City, you would be kind of reluctant to rely on one element of filtration alone. And what I mean by that is where we have HEPA filters or indeed standards filters on fresh air intakes, an awful lot of that is just around trying to filter out just dust and heavy soot particles. And I'm just wondering if you didn't have HEPA or any of the other UV or traditional filtration in place and you're relying solely on the needlepoint bipolar ionization that you mentioned there, how does that perform? Because I'm conscious of what we take from our filters, like when we replace them every 3 months on some of our sites because it's required. And I'm just wondering, how does this technology combat that?
Okay, so like I think I just want to cross, we are not suggesting you replace or remove your filtration. No, your ventilation filtration is there for reason and but this is an additional layer you add into your existing ventilation filtration system. So you have your filters capturing the high level dust or whatever, that's understandable. What this technology does is when you have inside, for example, these particles, right? I don't know if you have these particles which are less than 1 micron, right? 99%, if I may say, right? The challenge with these is they're virtually weightless, right? So they hang in the air. So think about how this bacteria and viruses spread. They spread human to human, right? So you're in a meeting room, your filters and, preventing dust, that's absolutely must because you don't want that, right? But inside, right? So this is an additional layer, Derek, right? You add that with a view that you actively address the pollutants inside the space. Does that make sense?
Yeah, no, that makes perfect sense. It's just from the comments you were making to Connor there, around the cost comparison. I thought you were comparing
No,
replacing the filtration with.
No, sorry, no, not at all. I think if you're in an office environment, let's say, right, for example, and think about, hey, you have a G4 filter, F5, right? What do you
Yeah.
do? A lot of times I've seen, upgrade the filters or mount UV as an additional option, right? What I'm saying is, hey, yeah, that could be one option, but the other option could be actually considering ionization for the fact and these things. Now, in certain settings and medical environment, you have to have filters. We know that, so we're not saying
Yeah.
replace that thing. But when you're considering and any additional air cleaning technology, you would say, actually, typical office environment, right? I don't know if you have G4 filters. That's kind of a perfect example, just for a layman's perspective. What we have seen in our test is, while having, let's say, G4, you're having ionization actually performs like F7, because it kind of addresses more particles. So your filters are doing much better. So,
Okay.
yeah. But when you go to upgrade the filters, or you say, look, we have G4, but we would like to have UV system, right? Then if you compare your cost versus ionization, then your cost is much lower. So no, we are not
Okay. Yeah.
replacing.
Understand there. Yeah.
Yeah.
Sorry, I misconstrued
No,
that
that's
with the
absolutely
comments.
it's a key point, and important. So
Yeah, so yeah, as you mentioned there, it complements the existing system rather than, Derek, perhaps replacing a HEPA. A HEPA is probably still warranted in some instances, honestly. I think.
correct.
Would you have to say, Alpesh? Yeah.
Yeah, it's an added layer, and the focus is like, like I said, how do you address these? So I just want to take a couple of minutes if that's okay, and I just want to recognize my partner for their support. Some of you may know, if I could take 1 minute, but IBC, who are the our distributors. So the reason I'm mentioning that, We'll of course follow up, Derek and Connor, with the follow-up information and brief read. So feel free to reach out to myself or Michael at IBC, and we'll support or further clarification, because I think 40 minutes of these with a bit of science is probably just gives you high-level flavor of what we do, right? So if you have any questions, applications, by all means, let us know. IBC are partners, so they have a kind of huge experience. They're based in Dublin. They kind of manage a number of brands. They have all the stock. These are the contact details of that. Again, they have a kind of dedicated team, great partners. So I just want to recognize and kind of take a minute for kind of mention that although I'm in London, I will travel around. But if there's a thing, then we could connect you to do that. I think Michael has sent me this photo. I think this latest product we have. So basically, this is just to give you, especially in FM environment, right? I don't want to have the duct mount or whatever system. Then we have this fan, which is called ion distribution fan. This is actually mounted in the IBC office in Dublin, and it has an inbuilt ionizer. So you replace that, you remove the ceiling tile, mount it there, and that's it. So what it does, it distributes ions right into space, right? And then ions, this typically covers about 150 square meters as an idea, right? So yeah, I just want to mention that I'm just going to stop sharing, and I guess if you have still questions, like I said, we'll send out the details, contact details. Connor, I'll probably send it to you and Derek, and feel free. And I just wait to hear if you have any more questions or.
Maybe one or two quick ones. So typically these are provided on the supply side, Alpesh. And is that like one per air handling unit on average generally, or?
So we have some application guidance and tools, but typically these are rated. So one module is rated for about 1,200 liters per second as an airflow. So we look at, okay, what is the space we want to look at the ventilation layout. So we have 2 or 3 different models. If you want to mount on AHU versus on the duct or on the grill. And then you say, look, I've got a 10,000 square feet space, maybe based on the airflow, we would say you need 2 or 4 or 6 of these. And then you'll mount on the supply side.
Okay.
Yeah.
My last question, it's a bit unusual one. Is it possible that we're eliminating too much from the air, and that after time our body, is less able to resist these bacteria and viruses?
Wow, this is a good one, because so the reason I'm laughing, because I originally am from India, right? And my parents are still in Mumbai, right? And if you know, Mumbai is not that bad place, but if you go to Delhi, the AQI index is always red, right? My dad's like 72. He says, he was joking. He says, oh, so I'm gonna breathe clean air now, and then as soon as I go out in the street, I can't cope up, right? But that's an extreme scenario. But I think so. Hey, listen, I could be biased, but there are lots of, if you think in environment where we are, right? You're doing, and I kind of mentioned about the layered approach, because with the layered approach, what you're doing is you're minimizing the impact. With everything we do, right? You make a cup of coffee, you carpet. We, as a people, we carry VOCs, right? We have as a body odor, things like that. So what I'm saying is we are continuously polluting the air around us, right? On top of what you're doing is continuously doing that. So to me, unless you're in a great countryside, and then everything's clean, then I understand you don't need it, and that's the thing. But I think my view to that is, we're continuously polluting. We are actually polluting even more with now a lot of things are doing it. So, you need something like this, right? You can never have too many ions or too much clear, because if the ions are too many, that's the benefit of bipolar, is positive and negative will eventually neutralize out. So you will never have too many ions, for example, right? You say, look, a small office. But that's my take on it. I think science might have a different view on that, but I believe, we are constantly doing things. I can see computer screens behind you in your office that produces electricity charges, for example, right? That kind of does product. So if you can minimize that, then I think we have loads of, if you go on a DEFRA website, and a link I can send you, you'll see, wow, and say, look, that's reality. But I think that's more of an explanation rather than answer. But I get it. It's an interesting one.
Just a thought.
No, absolutely.
Yeah, I'd like to open up to Adele, Michael, Kevin, Keith. Any questions yourselves or any comments?
No, we're good. We're familiar with the broad presentations. As I say, we've just engaged with GPS from the distribution point of view. So we're stocking the products now, and obviously we can assist with any scoping and exercises. We partner with some system integrators then in the marketplace to do the physical install So we talk to your HVAC guys or whatever, or we can arrange training for them, etc. It's pretty straightforward.
Very good. Okay. Look, if there's nothing else, we'll wrap it up. What happens from here is this recording goes to IWFM, and we'll be posting this link to that on LinkedIn for others to share. I think, you know, I certainly haven't come across this, this type of technology before. I kind of heard a small bit about it, but not to this level of detail. So, look, thanks very much for taking the time to put this together. Really appreciate it. Great to get the kind of technical learning also as part of what we provide with IWFM. And look, if anybody has any more questions, please do talk to Alpesh and IBC. I'm sure they'll be more than happy to support anything you need in that regards. So Alpesh, thanks again. Really appreciate your time. And thanks everyone else for joining us also. Have a great day.
Thank you. Thank you, Conor.
Thank you.
Thank you everybody for
Bye.
taking the time out. Thank you very much. Good day.